Good morning, ma'am. This is G. Krupabhishek from CSMB. Now I am here to explain my topic series and parallel combination of RLC and RL of resistors, indicators, and capacitors with their parameters. Introduction to series and parallel. Introduction to series and parallel combination of resistors, inductors, and capacitors. When resistors, inductors, and capacitors are connected in a series or parallel connection, they are totally independent, and other parameters change accordingly. Understanding how these components interact in series and parallel circuit is essential for designing and analyzing. In series combination, the total impedance is the sum of individual impedance, while in parallel combination the total impedance is reciprocal of sum of the reciprocals of individual impedance. Here is the circuit diagram of parallel combination of resistors, inductors, and capacitors. Series combination of resistors. In the series combination of resistors, the total resistance is equal to the sum of individual resistance. The total resistance RT in a series circuit junction can be calculated using the formula RT equals to R1 plus R2 plus R3 plus and so on Rn. The current flow through each of the resistor in a circuit is same. Here is the example. It is the circuit diagram of resistors in series. Parallel combination of resistors. In parallel combination of resistors, the total resistance is less than the smallest individual of resistance. The total resistance RT is parallel in a parallel circuit can be calculated using the formula 1 by RT equals to 1 by RT plus 1 by R2 plus 1 by R3 plus and so on 1 by Rn. The voltage across each resistor in a parallel circuit is same. Here is the circuit diagram of parallel combination of resistor. Series combination of inductors. In parallel combination of resistors, the total resistance is less than the smallest individual resistance. The total resistance RT in a parallel circuit can be calculated using the formula 1 by RT equals to 1 by RT plus 1 by R2 plus 1 by R3 plus and so on 1 plus 1 by Rn. The voltage across each resistor in a parallel circuit is in the same. Here is the example of series connection of conductors. Parallel combination of inductors. In parallel combination of inductors, the total inductance is greater than the largest individual inductance. The total inductance LT in a parallel circuit can be calculated using the formula 1 by LT 1 by LT equals to 1 by L1 plus 1 by L2 plus 1 by L3 and so on 1 by Ln. The voltage across each inductor in a parallel circuit is same. Here is the example of parallel connection of inductors. Series combination of capacitors. In a series combination of capacitors, the total capacitance is less than the smallest individual capacitance. The total capacitance CT in a series circuit can be calculated using the formula 1 by CT equals to 1 by C1 plus 1 by C2 plus 1 by C3 plus and so on 1 by C. The voltage across each capacitor series is the same. Here is the example of series combination of capacitors. Parallel combination of capacitors. In a parallel combination of series capacitors, the total capacitance is equal to the sum of the individual capacitance. The total capacitance in a parallel circuit can be calculated using the formula CT equals to C1 plus C2 plus C3 plus and so on. The current flowing through each capacitor in a parallel circuit is the same. Here is the circuit of parallel combination of capacitor. Series combination of resistors, inductors and capacitors. In the series combination of resistors, inductors and capacitors, the total impedance GT is calculated using the formula GT equals to root of R square plus x1 xi minus xc whole square, where x1 equals to 2 pi f L and xc equals to 1 by 2 pi fc. The phase angle theta between voltage and current in a series RL circuit is determined by the ratio of inductive resistance Xi to resistance R. The resonance frequency in a series RLC circuit is frequency at which inductive and capacitive resistance cancel each other out. Here is the example of series combination of resistors, inductors and capacitors. Parallel combination of resistors, inductors and capacitors. In a parallel combination of resistors, inductors and capacitors, the total impedance of GT is calculated using the formula 1 by GT equals to 1 by R plus 1 by inductive resistance plus 1 by 1 by XC. The phase angle between voltage and current is parallel RL circuit and determined by the ratio of R to index to resistance. The circuit frequency in a parallel RLC is the frequency at which the total. Here is the circuit diagram of circuit diagram of parallel circuit with resistance, capacitors and inductors. Thank you for listening my presentation.